And welcome everybody to the Daily Space Weather. I'm your host, Dan, aka smAsho. And we're looking at the southeastern limb of the closest star in ionized helium to see a coronal mass ejection propagating, as well as a spectacular filamentary collapse right in this area. I'll let it play through again. Whoop! There goes a coronal mass ejection, and there goes a filamentary collapse. Let it play through a second time here. A third time, rather. And there goes the filament, and there goes the collapse. This did indeed produce an Earth-facing coronal mass ejection. And here it is from the perspective of stereo A. Now, if you're wondering where stereo A is located, it's located at gravitational equilibrium point Lagrangian point 5, L5 as it's referred. Anyway, here's a view of stereo A's coronagraph, and you can see this coronal mass ejection propagating out here toward the right down the Earth-facing pipeline here. So a portion of this will most assuredly strike the Earth's geospace. It's a fairly moderate speed coronal mass ejection, and this is where Lagrange point 5 is located. So Earth would be off to your right from this perspective. Earth-facing coronal mass ejection. And of course, we forecasted this coronal mass ejection days ago, as our regular viewers would be well aware. So here we'll let this play through another time here, and then we'll show you the view from Lagrange point 1. Fantastic imagery here of this coronal mass ejection's propagation. So Lagrange point 1 is located about here, in between the Earth and the Sun, about 1 million miles from the Earth, about 92 million miles from the Sun. And here's the view from the LASCO C2. You're going to see ejecta on both sides of the obscurement disk here. And it actually shows up better in LASCO C3. So let's take down LASCO C2 and put up LASCO C3, also located at Lagrange point 1. Here's LASCO C3. And you can see the main ejecta here is this bubble. Not the bubble economy. It's different than the bubble economy, folks. The bubble economy is a bunch of overinflated stocks. So here you can see the ejecta coming out on the left, and you can see some coming out on the right as well, an indication that a significant portion of that coronal mass ejection is going to strike the Earth's geospace. So great view of that there from the LASCO C3. And this is not a classic halo coronal mass ejection where you see just a halo like this. It's pretty diffuse. The densest region is expected to miss the Earth to the east. In other words, this section right here is the most dense portion of the coronal mass ejection. But again, some portion expected to strike the Earth. We'll be talking about that and a lot more on today's Daily Space Weather. So Earth in the crosshairs, folks. Also, we'll be talking about a pink supermoon and how Musk is moronic. And let's get to it, as there's lots more stuff to cover here. So here's the sun in magnetogram, and there's actually 3 sunspot groups here. This is sunspot 2818, sunspot 2020, and sunspot 2021. Sunspot 2020 harbors significant possibility for additional solar flares. C and indeed M-class flares are possible from these regions. They have stayed fairly consistent here over the past 24 hours. Not a whole lot of magnetic changes happening here. The main changes happening are with 2818, which is this leading group right here. Here's another series of images here from the SDO. 304 angstroms. The southern hemisphere. Here's 171 angstroms, and we'll show additional close-ups in this wavelength toward the end of the video. Fantastic view of that filamentary collapse and coronal mass ejection there in the southeast. Here's a full disk, 304 angstroms view. We did see some C-class solar flares as well. We'll get to it. The likelihood for additional coronal mass ejections is still there, folks. We could still see additional ejecta. I would make it more likely on the opposite side of the sun, the non-Earth facing side of the sun, but there are filaments all over the North Pole and South Pole still. You can see some of them down here. These dark areas are filaments. There's also a coronal hole rotating in. We'll get to that too. First, a chart of the solar system. So tonight is the pink supermoon. We'll get to that as well. Here's where stuff is now. And we've advanced that a week to the 3rd of May. So pink supermoon tonight. It won't be pink. It'll be the regular golden color, advises the Farmer's Almanac. Here's USA Today's little video about the pink supermoon. Supermoon is caused by the moon being at its closest point to the Earth. And for all of you viewers in the U.S., the moon will be officially full at 11:32 Eastern Time on Monday. So 11:32 p.m. is close to when the moon reaches the apex of its path across the ecliptic also, folks, which will make it a very, very bright moon, especially if you've got clear skies. Go out and have a look. Take an image. Share it with us tomorrow or the next day. Perhaps we'll feature it on the channel. Happy pink supermoon, the April full moon. Here's a star chart. And once again, if you're up before dawn, you may see Saturn and Jupiter rising ahead of the sun. There's Saturn, David Icke's favorite planet. And for some reason, I can click on it over and over. There we go. Now I clicked on it and it worked. Saturn and Jupiter rising ahead of the sun. And the radio flux is at 79. The solar radio flux, the radio output of the upper chromosphere and lower corona, 2800 megahertz, otherwise known as the 10.7 centimeter radio flux. Here's a one-year chart of it to put it in context. The radio flux is this black line. The red line beneath it is the sunspot number, and we can expect a precipitous uptick in the radio flux coming any time. So here's the initial modeling of the coronal mass ejection. And this does not look like it's complete yet, so look for this to get updated today, folks. This is on the Space Weather Enthusiast dashboard. It looks like NOAA is calling for a strike of this coronal mass ejection to happen on the 28th. Around midday the 28th is when we're seeing the density spike forecasted by NOAA. Not sure I agree with that. I don't want to get too into forecasting the timing of it. No geomagnetic storms in the forecast, although we're currently in a condition of geomagnetic storm. Let's go to earthquakes next. If you're wondering what earthquakes have been shaken over the past 24, so do I. Largest of the past 24 was the 6.4 southwest of Tonga. So it's the deep earthquake capital of the world, folks. And indeed, that 6.4 was at 234.3 kilometers depth. Let's check out the rest of the last 24 hours. By the way, thanks everybody for the well wishes for Smash Staff. She's feeling much better today. Another deep quake near Saipan. We reported on one in yesterday's Daily Space Weather video. And we're just going to scroll up the list here. That 6.4 was the only major quake of the past 24 hours. Some U.S. quakes there on the west coast and in the western portion of the country. That 6.4 here near Tonga occurred at 22:28. So near 10:30 universal time there. That 6.4 magnitude quake. Looks like the second largest was a 5.4 at Peru. There was also a 5.2 at the Loyalty Islands, which is also south of Fiji. And continuing on to check volcanoes. VolcanoDiscovery.com has a Volcanoes Today page. Here's what's on the list. Sakurajima's exploded, 8,000-foot ash plume there. Suwanosejima exploded, 4,000-foot ash plume there. Ibu in Indonesia, now back on the list, 7,000-foot ash plume over the Indonesian volcano. Dakono, 7,000-foot ash plume there. Samisa Pochnoi, no volcanic ash advisory provided on that. Please don't fly your home-built kit aircraft over the caldera. Popocatépetl exploding. The Mexican volcano producing a 20,000-foot ash plume. Fuego in Guatemala exploding, 16,000-foot ash plume there. Revenador in Ecuador exploding, 14,000-foot ash plume in Ecuador. And Peru seeing explosive activity from Sabancaya, enough to produce a 24,000-foot ash plume. Another reminder from smAshomash.com to not pole vault the caldera. By the way, if you'd like some of this incredibly high-quality merch here, check out smAshomash.com. You'll find links to 3 different stores there. This one is the smAsho merch shop. And let's get back to data pertaining to space. It's the GOES 16 X-ray flux, part of its sun-facing suite of instruments. And we saw a C-class solar flare here. Peak flux happened at about 20 after 2 Universal Time on April 26th. And you can see that did produce some minor radio blackouts here over the western Pacific Ocean, where it created a radio hole in the ionosphere, the D layer. That's the deabsorption region. That's how radio blackouts happen, folks. The X-rays, they cause a disruption in the continuity of the ionosphere, which causes it to absorb as opposed to re-emit radio signals. Proton flux sees no spikes. As we forecasted, the coronal mass ejection that struck over the weekend was a glancing blow, and so no spikes in the proton flux there. No surprises there. Check out the spiky sawtooth patterns here on the GOES magnetometer. And this is the kind of thing you can expect to see when a coronal mass ejection strikes, as well as lots of solar activity affecting the GOES magnetometer as well. Check out all the sawtooth spikes on this. And for you new viewers, the N's and M's stand for noon and midnight local time for the GOES 16. Next, we're going to look at the polarity of the heliospheric current sheet. And you can see Earth is solidly in the green here, the North Pole-oriented portion of the current sheet, where we expect to remain for the foreseeable future. Here's a line-of-sight ecliptic plane field plot. A three-dimensional line-of-sight projection of essentially the same data. It also shows you the location of that blue line there is that's the B line, folks, the B line. And that's the extent to which one of the solar polar fields is charging up your portion of the current sheet. Here's a line-of-sight coronal hole plot. It shows you the sun's B field in blue. And it's surprisingly not really showing this coronal hole very well. This coronal hole over here, the north-oriented one, is actually about this big. So not showing up yet on the Gong 2 data there. There's the latest image. And also here is the detected filaments and detected sunspots groups imagery. So we still do see significant filaments down here in the southern hemisphere. Some of those are noted on the imagery. There are some up here in the north as well. Those are less noted on the imagery. 3 significant sunspot groups, especially sunspot 2020. Likelihood of significant coronal mass ejections and solar flares still there, folks. Continuing on. And the KP index has just come down from mild geomagnetic storm. This was a G1 geomagnetic storm, folks. Now down to a KP of 3. Back to calm conditions. Next, we'll take a look at the real-time solar wind, which has been fairly uneventful here over the past 24 hours. We did see a recent shift in the BT-BZ, which is the total field, that's the BT, and the BZ is the orientation from one of the poles of said field. It's recently shifted back into a northern BZ and a positive BT. current solar wind density quite low, 3.8 protons per cubic centimeter. Solar wind speed still elevated here, 454 kilometers per second, having been pretty steady over the past 24. Here's 4 hours of data from University of Michigan Geospace Model. Magnetohydrodynamic pressure in nanopascals from the Space Weather Modeling Framework. And we see a consistent pressure here, both on the bow shock side, which would be to your left, and the magnetotail side of the planet, which would be to your right. The magnetotail side, the portion not facing the sun. Here are ground magnetic perturbations, and we see some significant ones here, especially over the Canadian North Pole, less so over the Siberian North Pole. And yes, if you're a new viewer, we have two geomagnetic North Poles right now. The South Geomagnetic Pole has left the Antarctic continent entirely and is someplace down here, south of Australia, thousands of miles from the geographic South Pole. During this polar excursion, we see some odd equatorial pulses here. I've never seen that before. Look at this equatorial magnetic pulse. You can see a magnetic pulse stretching pretty much around the entire planet, right on the equator. That is a new anomaly that I've never seen before after covering this daily for about 3 years. So that is some interesting magnetic perturbation here. Geospace Delta B, folks, are changes in the Earth's B field in nanotesla. By the way, thanks to our BitChute subscribers, our Twitch viewers, etc. Thanks for interacting with us on social media and so on. We really appreciate that, despite the downfall of big tech and the pathetic joke that is the current state of affairs with social media. We wish social media would just simply do their jobs instead of attempting to control narratives that they know nothing about. BitChute.com/smAsho has some exclusive content. And we're currently streaming live to Twitch. We've decided to welcome Twitch for our cosmology segment once again today. Thanks to our YouTube subscribers, new and old. Don't forget to press like and subscribe if you're new here. Leave us a comment. Share the videos with your friends and foes. We've got lots of content. Check our playlists for more details on that. And here comes today's cosmology segment, where I'll talk in a stilted fashion for no apparent reason. Today's cosmology segment's going to start out with Elon Musk. Is he a moron? Well, I don't think he's actually a moron. He just has some idiotic ideas about certain things, such as carbon sequestration. Yes, we've decided to put Elon in the cosmology segment here because of the story about Mars. So Elon Musk is offering $100 million to 3 different prize winners to scrub carbon dioxide from the atmosphere. An idiotic idea, as carbon dioxide is not a pollutant and does not control the planet's climate, which is why this is so moronic. Scrubbing carbon from the atmosphere is one of the most idiotic ideas ever conceived by mankind. Let's continue on to another story about everybody's favorite billionaire, Elon Musk. Would you like to volunteer to go to Mars? Well, I wouldn't. Why? Because it would be fatal, most likely, especially around time of solar minimum. And why? Well, because you would receive a fatal dose of radiation. Even if you survive the trip back from Mars, I believe it takes about 10 months based on current technology to get to Mars, so about a 2-year mission, you're likely to die on the way back, and if not, from a series of cancers derived from all the radiation exposure. We need induction-powered shields, but beside that, Musk on Mars. A bunch of people will probably die, but it's a glorious yet idiotic adventure. Now, are you worried about an escape hatch? Are you worried about leaving the planet because the planet is going to get so hot that you're going to have to go to a different planet? Well, that's a moronic idea. It's absolutely idiotic. As idiotic as the idea that mankind can control the climate and that mankind does control the weather. Stupid ideas. And going to Mars, in my opinion, is an additionally stupid idea. There are very few resources or science to be done on Mars, in my opinion. Let's talk about, now, of course, the spectacle of going to Mars and so on, the accomplishment of getting humans to Mars and getting them back in one piece is quite an accomplishment, But what are the real rewards? What is the risk-reward ratio? Seems kind of low to me here at the Smash News Network, least busted name in news. Today's astronomy photo of the day is the Necklace Nebula. Now, this is actually a binary system, and this nebula is believed to be a planetary nebula. And those stars at the center of that, right there, are so close together that they orbit each other in barely a day. So the Necklace Nebula is today's astronomy photo of the day. That's not today's astronomy photo of the day. That's an article from SciTech Daily. We'll get to the astronomy photo of the day. By the way, the less glamorous name of the Necklace Nebula is PNG 054.2-03.4. I like Necklace Nebula better. And so this may be an interesting read for all of you cosmology buffs out there. Again, this one on SciTech Daily. A diamond necklace of cosmic proportions. Today's random number is 808, which coincides with a low-mass X-ray binary known as Sagittarius X4. So there it is on the XMM Newton. We do have this in some other layers as well. Let's take a look at it real quick on the 2-mass. And there it is in infrared light. Sagittarius X4, otherwise known as H1820-303, is a consistent X-ray source, and it does have a fairly consistent looking cyclicity here over the past 16 years. So that's the 16-year X-ray output, the daily X-ray output, and in the lower left is your 1-month X-ray output from Sagittarius X4. That's today's random object. It's number 808 on the Neil Gorell's Swift Observatory, the Burst Alert Telescope, which monitors 1,031 sources of X-rays. The astronomy photo of the day is a triple whammy, the Sagittarius triplet, consisting of M20, which is this nebula up here, M8, which is this nebula down here, and NGC 6559, which is this one over here. 3 nebulas, a triplet in the constellation Sagitta, in the constellation Sagittarius. And you're looking at about 100 light years. This is about 100 light years. That is M8 from the Messier catalog. And Messier was famous for looking up false comets, as Messier was looking for comets and cataloging all the blurry objects that were not moving individually across the sky, and ending up documenting a whole bunch of nebulae and galaxies. That's today's cosmology segment. And we'll have to say goodbye to Twitch. We'll bring you back for the meteorology segment. Next, looking in the realm of electron flux. And we see a more moderation here of the electron flux. Here's the 1-year chart. You can find that at solon.info. Here's a 3-day chart. The GO 16 greater than or equal to 2 mega electron volt electron fluence, back into a more moderate range, having been an electron storm area for several days here. We still do see some charging hazards here, mainly over Central America, southern Mexico, and about to move into the Central Pacific Ocean. Here's the forecast model. NOAA expecting level amounts of electron flux. That's the green box, the forecast. Here's a diagram of the Van Allen belts. We show it daily to keep people on the right page of what they're looking at. The Van Allen belts, there are usually 2 sets. During times of geomagnetic storm, we sometimes get a 3rd Van Allen belt. But in any case, distances here are in miles. Keep that in mind. Here is the total electron content forecast. So this is the total air column from your GPS satellite down to your handset. It'll tell you where GPS errors are likely to occur. We show it daily on the Daily Space Weather. And we see quite dense bands of electrons here. I'll let it play through a second time. And your GPS is most likely to produce massive errors around the equator at noon. Here's another diagram of the atmosphere. We featured this yesterday in yesterday's Schumann Resonances video. If you didn't watch that, go check that out. That's on the Smash News Network playlist. This shows you things like the penetration of electromagnetic radiation, the temperature of things like the thermosphere, as well as the density of different chemicals. You can see ionized oxygen, much more common at the high altitudes here than molecular oxygen, atmospheric oxygen, O2 as we call it. And we're showing you this because the F, right there, the F layer, is the next frame. Here is the F ionosphere layer, showing you vibrational frequencies in megahertz. And we'll give this one a moment to play through. It's showing you a full day at 15-minute intervals. We see some anomalies here around the equator. Some ahead of the sun charge-ups happening there. As well as some large low-frequency regions. Large low-frequency regions there in the ionosphere. You can see all those yellow blobs there. Those are only 2 megahertz. And the red would be 1 megahertz. That would be the F layer. When you see a red blob, folks, that means it's only one layer. It's the F ionosphere layer. Anyway, there's the latest image from 9:30 Universal Time. And let's bring back Twitch. Hey, Twitch, welcome back. It's the meteorology segment. And we'll be talking about how, oh my God, the Earth is burning up. We're all going to die. It's so hot that it's cold. The Northern Hemisphere sees 4 winters of record snow mass balance and all kinds of cold records and snow records broken. But apparently the planet is so hot that it's cold, which is a real argument by people who know nothing about the climate, geologic record, etc., atmospheric physics and so on. Experts say humanity faces a grim and ghastly future. State of planet is much worse than most people understand. Now, I would tend to agree that the state of the planet has all kinds of issues. The collapse of bee colonies, all kinds of glyphosate in farm runoff, all kinds of pollution. Contrails count as pollution. There's all kinds of problems, folks. Covidiocy is a problem. Plastic in the oceans. There are all sorts of real problems. However, carbon dioxide in the atmosphere is not one of them. Carbon dioxide is not, never has been, and never will be a pollutant on planet Earth, most likely. And optimally, carbon dioxide would be at levels of 1,200 parts per million. That's not going to cause the planet to warm up either. The planet warming up causes an increase in carbon dioxide because warmer oceans cause carbon dioxide to evaporate out of them, as cold water has a higher capacity to sequester carbon than warm water. And I won't continue on with this nonsense. This article, alarmist BS from some guy in Australia, called Corey Bradshaw of Flinders University in Australia, humanity is causing a rapid loss of biodiversity, and with it, Earth's ability to support complex life. But the mainstream is having difficulty grasping the magnitude of this loss despite the steady erosion of the fabric of human civilization. I would tend to agree with that. The fabric of human civilization is being eroded by ignorant fools, covidiots, climate alarmist imbeciles who know absolutely nothing about atmospheric physics, trying to scare people into coming up with idiotic ideas for non-existent problems. Let's take a look at the jet streams. Here are the jet streams of the Western world. Look at how chaotic they are. They are all over the place. They're blowing north and south. They're tripled up and so on. We've got warm air blowing to the poles. We've got cold polar air blowing down to southern Greenland and so on. We've got doubled up and tripled up jet streams in the southern hemisphere. Here are the jet streams of the eastern world. We'll rotate it far enough to see New Zealand. And you can see, once again, doubled up jet streams here and very chaotic jet stream flow. In fact, this area right here, whoops, this area right here, the Western Pacific, the jet stream is blowing east to west, which would be backwards. How about a real-time lightning map? And we've seen actually very low levels of lightning for the past several weeks, at least overall on a global scale. And we just saw some errant lightning bolts come in once again as we do the video. This one in Wisconsin, not far from Minneapolis. Anyway, there's your global lightning map. We show it most days as well. Here's your pressure map. And let me just check the life of the stream real quick. And it looks like everything is A-OK. Not to be confused with AOC, who is far from A-OK and knows nothing about atmospheric physics. Speaking of atmospheric physics, here is where pressure cells are located. We're going to advance this into the GFS forecast for tomorrow. There's the GFS pressure forecast for tomorrow at noon Eastern Daylight Time. Continuing on, here's the U.S. Doppler radar map. Heavy snow falling in northern Wisconsin once again, as well as on the northern peninsula of Michigan, as well as central Michigan, and lots of moisture over the entire northwest portion of the country. Some rain falling in Maine as well. Here's the map of the cloud layer. It's the NASA GOES interactive weather satellite. And you can see a giant atmospheric lake over the western portion of the U.S. Again, there's the cloud layer. Low clouds over the western Atlantic. You can see those low clouds there. And we'll have to say goodbye to Twitch as this meteorology segment is complete. Back to the daily space weather. It's bonus features. Here's imagery that's not even 2 minutes old from the El Teide, Spain Solar Observatory. Massive filaments down here in the southern hemisphere that you can see there. Again, likelihood of additional coronal mass ejections as well as solar flares quite high right now. And you can see filaments in the north as well, overlapping the limb of the sun. This is in hydrogen alpha, 6,562.8 angstroms. Thanks, Smash team, for tuning in. Thanks to our new patrons. Our patrons are the true source of content for these videos, as we make just this side of nothing on YouTube. So please share the content with your friends and foes, even if you're unwilling to open up your cobweb-encrusted wallets and shell out $3 per month or more. There are multiple tiers on Patreon, patreon.com/smashamash. Thanks again to our patrons, our new and old patrons. Cheers. You're helping us out a lot. Next, we've got bonus imagery here. The colorized magnetogram of 3 sunspot groups, as well as the intensitygram. There are your sunspot groups in intensitygram. Here are your sunspot groups in magnetogram. 2818, 2820, and 2821 is this alpha class up here. 3 significant sunspot groups side by side, all in the Earth-facing zone. And as these move past the Earth-facing zone, the likelihood of large solar flares actually goes up due to what we call the Earth-facing quiet effect. Let's close things out with some more views of the closest star, the local yellow dwarf, El Sol. If you've got comments to leave directly for the sun because you think it's conscious, leave them in our comments. Perhaps we'll read them at a later time. And here is a close-up of the southwestern portion of the Earth-facing solar disk. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics. Don't drink it. If you do, don't drive. Seriously, don't drive. I might be out there, and I don't like traffic. I like you. I just don't like traffic. And welcome to the Neo Renaissance. Visit our links, support the channel. And since it'll never be now again, may that solar wind be at your back.